JUICE, ESA's first mission to Jupiter, is an important step closer to launch. The spacecraft was built by a consortium of industries led by Airbus in France, and it has just completed 4 weeks of thermal testing in the Netherlands at the Space Agency's ESTEC facility, Europe's largest satellite test centre.
It is true that the JUICE spacecraft that we can see on the background is going to be launched in space, meaning that it's not like for aircraft. We can repair something after a couple of hours of working. We need to make sure that before we launch, everything will work properly as expected.
The spacecraft's thermal design must therefore be able to withstand an extreme range of temperatures to protect its structure and onboard electronics and instruments. To ensure it can do this, it goes through a rigorous test campaign where it is monitored as it is being operated around the clock, 24/7. ESTEC's large space simulator recreates the conditions of JUICE's journey in space. It's Europe's largest vacuum chamber, and its internal black panels, which are filled with liquid nitrogen, were used to cool the environment down to around minus 180 degrees Celsius. But there's also a need to test against extreme heat, up to 250 degrees Celsius, for what the spacecraft will experience when it will swing by Venus on its long way to Jupiter and come even closer to the Sun beyond Venus's orbit.
To reproduce the heat side of space, so when we go close to the Sun, we simulate the Sun. And in order to do so, we have a set of lamps, very powerful lamps that are reflected in 121 mirrors that can be reconfigured depending on the mission characteristics. And in this case, we simulate the heat of the Sun while the spacecraft goes through Venus. Why Venus? Because the JUICE mission is doing a flyby in Venus before going finally to Jupiter.
Once at its destination, it will study the giant planet's atmosphere, magnetosphere, and 3 of its many moons, Europa, Callisto and Ganymede, for over 4 years. And to ensure that JUICE and its 10 scientific instruments will be in perfect working order on arrival, it also has around 500 multi-layered insulation thermal blankets, more than most of the European spacecraft flown so far.
So JUICE is a very exciting mission, so we are going to explore Jupiter in details, and in particular I would like to know whether there are conditions hospitable for life around a gas giant like Jupiter, and we are going to focus that on the 3 icy moons, which are Europa, Ganymede and Callisto, and we would like to know whether inside those moons there are conditions which are interesting for life. And we are going in particular to explore the liquid water which are underneath the crust of those moons.
Each of these moons is the size of a planet and will allow us to understand where in our solar system we can find conditions suitable for Earth-like life. The JUICE mission will also give exciting hints about life-friendly conditions in planetary systems around other stars. There are now several more months of testing ahead before JUICE is finally ready for launch in 2022 to explore our solar system's largest planet and 3 of the 4 intriguing Galilean moons.